Hey guys, we're back here with more transformations. Okay, we're just going to walk through 6 examples. We got 1 and 2 up here. 3, 4, 5, and 6 are right there. You could pause the video, and if any of those are ones that you want to check out, you could skip ahead and do that. Okay, but back to the action here. Jumping into number 1. Okay, number 1, y equals -2, parenthesis x plus 1 squared plus 6. Again, these big complicated ones they can be scary. I can't deny that. But again, if you are confident with your process of the way that we've done things thus far, you should be fine. These aren't that scary. If you know what to look for, again, having this equation there as you do it helps as well. But yeah, just one thing at a time. Don't be scared by the size of these equations. Okay. As always, identify your parent function first. So this is a quadratic, and you draw that. There we go. So I drew my parent function quadratic up there as a reference point. Okay. And then I look at my equation and I identify what are my transformations that are happening. Okay, and I've got 4, holy cow, 4 transformations here. Okay, what are they? They are, well, let's do the h and k first. Okay, so this plus 1 in the middle with x is telling me left 1, and then a vertical shift of positive 6, so that's up 6. So those right there influence where my origin point is, my new origin point. Okay, so let me shift that here first. So left 1, up 6. So that's where my new origin point is. Okay, and so once I shift that, I'm basically done with those. These shifts don't really have an influence on kind of the shape of the parabola after that. Okay, so there's 2 parts to this. I know it just looks like one number, but there's 2 parts. Okay, there's that negative. Okay, so that means there's a vertical flip. Okay, a vertical flip, right? So instead of opening up like a smiley face, this is going to be a frowny face. And then that 2 right there, right? That's what we just learned, that multiplier. So 2 times multiplier means a vertical stretch. A vertical stretch. Okay, so 4 things. I took care of 2 of them. But as I draw my points of the rest of my parabola here, I'm going to have to keep these 2 things in mind. So again, what might be helpful to you is to either draw like a new x-axis, right? Because that's what this is going to be reflecting over. And what also might be helpful is to just draw where your points would be if it didn't have any of these things. That's what I've done before, because that gives you a reference point to follow, okay? So my origin's here, okay? My normal parabola would be shaped like this, but instead I'm going to flip those. So this is tricky. I'm going to flip those, and I'm going to do a vertical stretch of 2, okay? So it's going to be a double thing to keep track of here. So from this origin, the 2 times multiplier, right, that means I would normally move up, right? That means I double the amount that I move up or down. So normally I would move up 2 instead of up 1. But again, it's a vertical flip too. So instead of counting up, I'm going to count down that double amount. So down 2 over 1. So I'm going to have a point here and a point here. So I hope that makes sense. That's these 2 things right here. I'm flipping it down and I'm doubling the distance, okay, that those points usually would be from my origin, okay? Same with these 2 points. These 2 points are usually up 4 and over 2 away from my origin point. Again, the distance is going to double from 4 to 8. And instead of going up, I'm going to go down. So down 8 would be 2, 4, 6, 8. And then right 2 would be here. And then left 2 would be here. And it's all using that new origin point as your reference point, okay? So that's what this would look like, okay? That's what this would look like. And you might be saying, how do I know that's right? I counted it. I think I did it all right. Desmos is your best buddy here. Graph this in Desmos. Type that into Desmos and see if it matches what you have, okay? Just use it to check your answer, because you do need to know how to do this by hand. So then domain and range for this one, okay? Domain, as with all quadratics, is going to be all real numbers. This will get wider forever. And then the range, again, does not go up and down forever. The highest it ever gets is 6, okay? And it hits all the y values below that. So we'd say y is less than or equal to 6. Number 2, y equals 1/4 quantity x minus 2 cubed. Okay, cubed. So my parent function is cubic, right? Because that's 3 exponent. Okay, so let's draw the cubic graph. Both cubic and cube roots have these 3 points, okay? But again, the cubic is taller, and then the cube root is wider. So these are the taller ones. So we have 2, 8, and -2, -8. Okay, so that's my parent function of my cubic graph. And then I look at my equation and I determine, okay, what is the shifts? What are the transformations? And here I just have two, actually. I just have two. Okay, I have that minus 2 h value, which means that's a shift of right 2, and this 1/4 as an a value. Okay, so it being a fraction smaller than 1, I would call that a 1/4 multiplier. And another name for that, another thing we could say about that is it's a vertical shrink. It's a vertical shrink, meaning it's going to be like pushed down this shape. So let's think about this. My origin point is going to be shifted over right 2. So right 2, and there's no vertical shift, so that's where my new origin is going to be. And now with a 1/4 multiplier, okay, again, that affects the vertical distance that I'm counting, okay, from point to point. And so I'm going to cut those in fourths. I'm going to go a fourth of what I normally would, okay? So again, these points normally would be here and here, but in reality, I'm going to go up a fourth of what I normally would. So instead of going up 1 right 1, I'm going to go up just a fourth in right 1. So it's like barely above the x-axis here, like right there. So up a fourth and then right 1, and then normally it's right left 1 down 1. Now it's going to be left 1 down a fourth, right? Because that, again, vertical distance is cut in half, or cut in fourths. So that is where these 3 points would be in relation to my new graph. And then these two as well, right? Normally I count up 8, right 2. 8's easy to cut in fourths because 8 divided by 4 is just 2. So I go, instead of up 8, right 2, I just go up 2, right 2 for my new origin. So up 2, right 2, and then same thing. This is normally down 8, right 2. Instead, it's going to be down 2, left 2. Right? Kind of a smushed together version of this graph. And then for this one, domain and range. So again, domain, all real numbers. This will get wider as it expands. And then the range is also all real numbers. It goes up and down forever. Okay? So that is 1 and 2. Let me jump into 3 and 4 once I erase this. Okay, 3 and 4 from over there, they are now on the board. Let's do them. Okay, so y equals 1/2 times the square root of x minus 3, minus 3, double minus 3. Okay, so again, same process. Square root is your parent function. So you draw the square root parent function graph on your grid here. So it's the cannonball, 0, 0, 1, 1, 4, 2, 9, 3. And then you look at your equation and you determine your transformations. So my transformations here, we've got 3 of them. Minus 3 inside a group with the x means that is a horizontal shift. And then horizontal being a minus 3 means right 3. Okay. That k value, this minus 3 separate from the x, is a k value. So that is a down 3 shift. Okay. And then this a value being 1/2 means, right, that's a 1/2 multiplier. So that means that is a vertical shrink, just like number 2. Okay, so these 3 things are happening to this graph. Okay, so the right 3 and down 3 are happening to the origin point. So right 3 and down 3 here. Okay, and then the 1/2 multiplier, right, means normally, right, I would count. Let me draw that because it's helpful. So I'd normally go up 1 over 1, have a point there, up 2 over 4, and have a point there. And I'm not able to draw this 9, 3 because it'd be too far off my graph. But yeah, these would be where they normally are, okay? And what I'm going to do is cut the distance, cut the vertical distance in half. So instead of going right 1 and up 1, I'm going to go right 1 and up 1/2. That's where that actual point's going to go. Okay, let me erase my guide point there. And then for this one, instead of going right 4 and up 2, I'm going to go right 4 and up 1. Cut that vertical distance in half, okay, because of that half multiplier. All right, so this is a vertical shrink, meaning it's like somebody pushed together my cannonball-shaped graph here, and it does look like that. It's a not as wide of a curve, okay? So then domain and range, this is going to be interesting here, okay? Because it's not all real numbers for either one, right? So I think, okay, does not go left and right forever for the domain. So I think, okay, where does it stop, or what's its limit? And on the x-axis, it's here, right? It's at +3 on the x-axis, okay? and it hits every x value above that, right? So I would say x is greater than or equal to 3 for my domain. And then range up and down, range, right? It's going to go up forever very gradually, but yeah, this line will eventually go up forever and ever, okay? And, right, it never goes below -3 on the y-axis, right? So we'd say y is greater than or equal to -3, okay? So that's for that one. Very good. Number 4, y equals 3x squared minus 5. Now this looks different, right? This looks different than the other ones we've graphed. So you might be saying, is that even a graph of a transformation? And it is, right? This just doesn't have an h value kind of within this equation. So we're just going to have to skip that part. But it does have an a value and a k value, okay? So we do still graph this like a transformation, okay? But parent function first, this is a quadratic. Okay, so I draw that like so. And then I look at my equation and I determine my transformations. So transformations, I've got 2 of them. This -5, again, it's kind of next to the x, but it's not in a group with it. It's not in parentheses with it. So it's not an h value, it's a k value, which means that's a vertical shift of down 5, okay? And then this 3 multipliers right here. So that's a 3 times multiplier. 3 times multiplier means it is a vertical stretch. Vertical stretch. Okay. So let's draw that. Okay, let's draw that. So I'm not shifting at all to the left or right. It's going to stay right in the middle, but just shifted down 5. So the origin shifts down 5 right here. And again, that 3 means I'm going to triple the distance that I normally would vertically. So normally I'd go up 1 and over 1 to both sides. Now I'm going to go up 3 and over 1 to both sides. So that is where my first pair of points are. So the next points would be normally up 4 and over 2 to both sides. Now a triple 4, which is 12. So I'm going to go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 12 and over 2 to both sides. Again, just the vertical distance triples. The horizontal stays the same. So this didn't quite go through there, but that's all right. This graph looks like that, a much skinnier, stretched out vertically parabola. Okay, now domain and range here. Domain, like all parabolas, is going to be all real numbers. Range, okay, does not go up and down forever. Goes up forever, but it only goes down to -5. It's the lowest it ever goes. So y is greater than or equal to -5 is my range. Alrighty, 3 and 4 are there. 5 and 6 coming right after this.